Welcome to my kcse revision channel. Teacher James Marita, Grigori Boys High School. Kindly subscribe my channel. Click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision. Our topic is nitrogen and its compound. So we have the questions on laboratory preparation of ammonia and the questions on laboratory preparation of nitrogen 1 oxide. So I have the two diagrams. So if I can start from the first diagram, this is the laboratory preparation of nitrogen 1 oxide. What are the reagents here? The reagent is just ammonium nitrate. In the presence of heat, ammonium nitrate can decompose to have the nitrogen 1 oxide gas, and then we have water. So the gas produced here is normally collected over warm water. The reason why this gas is collected over warm water, the gas is fairly soluble in cold water, but insoluble in warm water. That is a property that makes this nitrogen 1 oxide to be collected over warm water. So what are some of the expected questions that you are required from this particular diagram? One is by be able to write the correct chemical equation when the ammonium nitrate is being heated. So when ammonium nitrate is heated, it will decompose in the presence of heat. We have nitrogen 1 oxide, and then we have water vapor. Now, what is the precaution that is required when carrying out this experiment? One of the precautions is that the delivery tube should be withdrawn from the water to avoid the sagging back. So this delivery tube, before heating is stopped, before you stop heating this one, the delivery tube must be withdrawn from this water here to prevent water from sucking back, which might break the round bottom flask. And the second precaution, you can also say that the round bottom flask, as you can see from your screen, is that it should be slanting downwards from left to right. And the reason why this one is slanting downward from left to right, it is to prevent water formed from flowing back, which may crack the round bottom flask. And another thing that you are supposed to know, why do we use the round bottom flask? A round bottom flask is used for such that it can have a large surface area for the equal distribution of heat. Now, what is the drying agent? The drying agent for ammonia, the drying agent for nitrogen 1 oxide. Nitrogen 1 oxide, it is just dried by passing it through a concentrated sulfuric acid. Concentrated sulfuric acid can be used to dry the nitrogen 1 oxide gas. Now, to test that the gas produces nitrogen 1 oxide gas, you are required to describe an experiment. For instance, describe how nitrogen 1 oxide is tested. You can just say we know that this gas normally supports combustion because during the decomposition, the heat will decompose this nitrogen 1 oxide to nitrogen gas and oxygen. Oxygen will support burning, and that is why the nitrogen 1 oxide is also supports burning. So to describe that the gas produced here, that the gas produced in nitrogen 1 oxide, you carry out an experiment or you describe an experiment whereby when a glowing splint is introduced in a gas chamber suspected to contain nitrogen 1 oxide, what will happen here? It relights a glowing splint. But what will happen here? The heat makes the nitrogen 1 oxide to decompose into nitrogen and oxygen. The oxygen now here, it relights the glowing splint. Or we can say that oxygen it is the one that supports combustion. That one now you will confirm that the gas produced is nitrogen 1 oxide gas. Then we have at least one physical property of this nitrogen 1 oxide. It has a pleasant smell, and again the gas is denser than air. Therefore, apart from being collected over water, it can be collected by the downward delivery method or the upward displacement of air. Then we have the property that makes this nitrogen 1 oxide to be collected as shown on this diagram. Remember, this gas, it can be collected by the downward delivery method or the upward displacement of air, but also this gas, it can be collected over warm water. Now, what property that makes this gas to be collected over warm water is that the gas is fairly soluble in cold water, but insoluble in warm water. And that is the property that makes this gas to be collected by this method that you have seen there. Then at least one use of this nitrogen 1 oxide, just to say that it is used to produce flames in analytical work. It can be used as an oxidizer in the racing engine. It can also be used as an anesthetic during surgery. So those are some of the uses of that gas. That is a simple summary of the laboratory preparation of nitrogen 1 oxide, and these are some of the expected questions that you are supposed to be asked from this particular diagram. In my second diagram, we have this is the laboratory preparation of ammonia. Initially, ammonia cannot be prepared by the method that as you can see here. You see that the orientation of the conical flask is pointing upward. That is a mistake. Another thing we have a moist reagent, which is used instead of a dry reagent. So during the preparation of ammonia, laboratory preparation of ammonia, the reagent which can be used to prepare the gas, they must be dry. Reagents must be dry. A mixture of ammonium chloride and calcium hydroxide must be dry. Apart from having a mixture of ammonium chloride and calcium hydroxide, we have also heating a mixture of soda lime. That is the potassium hydroxide and the ammonium salivate. They must be dry, a reagent which is used to prepare that gas. And again, the orientation of the conical, around the bottom flask, it should be pointing downward. The orientation, this one must be pointing downward from left to right, because to prevent the water from running back, which might break the the round bottom flask. The dry ammonia gas must be collected by the upward delivery method. Once the gas can be dried using the quicklime or the pad line, or we can also say that it is calcium oxide. The gas can be dried using calcium oxide. Once the gas has been dried, it must be collected by the upward delivery method. So now from this diagram here, there are some of the questions that you will be asked here. This one normally comes in an examination whereby you have a moist mixture of ammonium chloride and calcium hydroxide. Then we have, of course, heat. Then we have a drying agent. The orientation of this one is pointing downwards. It should be pointing downwards, but here it is just pointing upwards. Then once the gas has been dried, it must be collected by the upward delivery method, but as you can see from here, it is collected by the downward delivery method. So the first question that you will be required to answer from here, it is to identify the mistakes. And in each mistake, you are supposed to give the reason for each mistake. So the first mistake, the methods of the gas collection is wrong. The reason for that one is ammonia is less denser than air. Being less denser than air, it must be collected by the upward delivery method. Mistake number 2, the flask is landing upwards. You can see here. Instead of landing downwards, it is just landing upwards. Reason for that one is water produced may run back and break the round bottom flask. Another mistake, we have a moist reagent. A moist reagent cannot be used for the preparation of ammonia gas. So we have the reagent must be dry. So the mistake there you can say moist reactant should not be used. The reason for that, ammonia gas will just dissolve in water. So that is the mistakes you can be able to identify from this diagram. Then again, we have the drying agents for gases, likes of concentrated sulfuric acid, likes of calcium oxide, likes of fused anhydrous calcium chloride. Those are some of the reagents which are used to dry some gases. Here in this case now, there is a suitable drying agent for ammonia gas. The only suitable drying agent for ammonia gas, it is just calcium oxide. So you can have this calcium oxide, or this one can also be called, we call it this one as a quicklime. Quicklime is calcium oxide, or this one you can also get the other time we call it the panthelide. So this is the most drying agent for ammonia gas. Once the gas has been dried using this reagent, it can now be collected by the upward delivery method. Again, now we have, how do you test for ammonia gas? Describe how ammonia gas is being tested. Ammonia gas, normally, it reacts with the concentrated hydrochloric acid, it forms a dense white fumes. So to describe an experiment or to give just a procedure to be followed, that how is this gas being tested, you dip a glass rod into a concentrated hydrochloric acid and bring it in contact with ammonia bring the contact with ammonia in the test tube. What you will use here to observation is there is a dense white fumes are formed, and that one will confirm that the gas produced is gas produced as ammonia. You might also require the question for the reaction. You will have a dry ammonia gas reacting to dry calcium hydroxide, then you will collect ammonia gas, and of course you have water, then you can have the calcium chloride. The question must be well balanced with the correct chemical symbols. We can also have another pair of reagents. Instead of having a dry ammonia, ammonium chloride, and another calcium hydroxide, another pair of reagent is a soda lime, that is sodium hydroxide with a dry ammonium salivate. When that mixture is being heated, we can also collect the ammonia gas there. Then we have that the most suitable drying agent for ammonia gas is calcium oxide. Then why that concentrated sulfuric acid cannot be used? Why that anhydrous calcium chloride can be used? So anhydrous calcium chloride or the concentrated sulfuric acid cannot be used to dry ammonia gas just because ammonia gas will just react. Ammonia gas will react with the concentrated sulfuric acid to form ammonium salivate. It can react with the anhydrous calcium chloride. Therefore, those two reactants cannot be used to dry ammonia gas. That is a simple summary on laboratory preparation of ammonia gas, the expected question, laboratory preparation of nitrogen 1 oxide, and the expected question. You can go through it. Don't forget to subscribe my channel, watch, and share. Thank you for watching.